So learning targets 7.5 through 7.8 are all going to be together on the test looking something like this, and something like your worksheet 7.8a and 7.8b. When I look at this first equation, I see only an x squared term and a constant, so I know I'm going to solve using square roots. And the reason is because there are only x squared and constant terms. So I take the equation x squared minus 36 equals 0. When I add 36 to both sides of the equation, I'd get x squared equals 36. And then to undo the square, I would square root both sides. Don't forget you're looking at both the positive and negative square root of 36. So x equals negative 6 is one solution. X equals positive 6 is the other solution. When I look at this one, I see all three types of terms. The coefficient of x squared is positive 1, so I'm going to factor. Why? Because the equation has all three terms and the coefficient of x squared is 1. So to factor this, x squared plus 8x minus 48 equals 0. I'm looking for numbers that multiply to give me an answer of negative 48. So 1 and negative 48, negative 1 and positive 48, etc. But add to give me a sum of positive 8. And I can work through all of my factor pairs of negative 48, and what I'm going to find eventually is that x minus 4 and x plus 12 will work. Negative 4 times positive 12 is negative 48. Negative 4 plus positive 12 is positive 8. So then, two things multiply together to give me 0, which means x minus 4 could equal 0. Add 4 to both sides to get x equals 4. Or x plus 12 equals 0. Subtract 12 from both sides to get x equals negative 12. Those are my two solutions. Most of the time, I would expect to see two solutions. This has all three types of terms like the one before it did, but not only is the coefficient of x squared not 1, but it's not a common factor that I could pull out of all three of these. So I'm going to use the quadratic formula because the equation has all three terms and the coefficient of x squared isn't 1 and isn't a common factor. So I start with 4x squared plus 6x equals 7. But then I actually have to do some solving here. I need to get the 7 on the other side of the equation. So 4x squared plus 6x, I would have to subtract 7 to move it over, so minus 7 equals 0, which means a is 4, b is 6, and c is 7. So into my quadratic formula this goes. X equals, big long fraction bar, the opposite of b. So b is 6, so this becomes negative 6, plus or minus the square root of b squared, so 6 squared, minus 4 times a, which is 4, times c, which is, negative 7. That's a mistake on my part, negative 7, all over 2 times a, which is 4. So all I did was take the quadratic formula and substitute in my a, b, and c. This simplifies to x equals negative 6 plus or minus this big square root that I'll figure out what that equals, and then 2 times 4 is 8. If I take in my calculator 6 squared minus 4 times negative 7, I get positive 148. So to find my two solutions, I need to do one of these equations with this plus and one with the minus. So x equals negative 6 minus the square root of 148 all over 8 is one of my solutions. X equals negative 6 plus the square root of 148 all over 8 is the other solution. Don't forget when you put it in your calculator, put negative 6 minus the square root of 148 equals before you divide by 8. So this x, rounded to 2 decimal place, is roughly negative 2.27, and this x, rounded to 2 decimal places, is roughly 0.77. So those are my two solutions. The next one, I look and I see the same kind of thing. I see all three terms. The coefficient of x squared not only is not 1, but it's also not a common factor. So in this case, everything's on the same side already. So a is 5, b is negative 3, c is positive 10. So x equals, big long fraction bar, the opposite of b, but b is negative 3, so the opposite of that is positive 3, plus or minus the square root of b squared, so negative 3 squared. Do not forget those parentheses. They are necessary, required. They don't mean the same thing if you don't have them. Minus 4 times a, which is 5, times c, which is 10, all over 2 times a, which is 5. Now when I simplify this, the 2 times 5 becomes 10. The 3 over here stays with 3. What's underneath the radical, though, when I take negative 3 and square, then subtract 4 times 5 times 10, I end up with negative 191. In the real number system that we're working with this year, you cannot take the square root of a negative number. So this is no solution, which means if I graphed this equation, this parabola would never cross the x-axis. I'd get a parabola, but it just wouldn't cross the x-axis. This next one, I look and I see all three terms. The coefficient of x squared is positive 1, so I would solve, and the one above that I would use the quadratic formula. This one I would solve by factoring. The equation has all three terms, and the coefficient of x squared is 1. So I go, and I did make a typo on this, and I fixed it on my sheet, but I forgot to fix it on yours, so it should be x squared minus 10x plus 21 equals 0. And I forgot to fix that. So x squared minus 10x plus 21 equals 0. I'm looking for values, numbers, that multiply to give me positive 21 and add to give me negative 10. Well, I can get a positive 21 by multiplying two positives with two negatives. Since they have to add to be a negative, it has to be two negatives. And I go through the factor pairs of 21, and 3 times 7 is 21. So negative 3 times negative 7 is positive 21. Negative 3 plus negative 7 is negative 10. So two things multiplied together equals 0, which means either x minus 3 is 0, or x minus 7 could also equal 0. I'm going to add 3 to both sides here, so x equals positive 3 is one of my solutions. Add 7 to both sides here, so x equals positive 7 is the other solution. And the last problem is this one. Boy, I noticed that it only has a squared term and a constant again. So only squared term and constant, I'm going to use square roots. So I have this, x minus 8 quantity squared plus 2 equals 102. First I would get this constant. Keep the thing is being squared by itself, so get this constant off of this side. By subtracting 2 from both sides, get rid of this plus 2. So I'd have x minus 8 quantity squared equals 100. To undo this square, I would have to square root. So x minus 8 quantity squared, the square root of that, equals positive and negative square root of 100. Two different equations here. Square rooting this side gives me x minus 8 both times. The right side, though, once it's negative 10, and the other time it's positive 10 from that plus and minus. When I add 8 to both sides here to solve for x, I get x equals negative 2. Add 8 to both sides here to solve for x equals positive 18. So if I graph this parabola that crosses the x-axis at those two places.